But basically, let's look at the agenda. Today we're sort of introducing our new module on prompt engineering for coding education called AI Engineering Lab. And today I'll quickly talk about sort of what this new challenge in coding education is, why prompt engineering matters. Then I'll go ahead and introduce our new module that's really designed to teach students AI skills, especially how it relates to coding. And this is especially useful for non-CS majors, but also definitely has a use in main CS education as well. I'll also go through a live demo of a new question type we're introducing with this called prompt problems, and the AI assistant that we've launched in December of last year. And then finally go over some next steps, like the launch schedule for this module, and pricing for this as well, for both like customers and non-customers of CodeGrade. And then finally, we'll have some time for Q&A. I expect this whole presentation to last about 30 to 40 minutes, so there should be enough time for some questions at the end. While the webinar is going on, feel free to put like questions in the chat as well if anything is unclear, and we'll make sure to answer all of those questions. But without further ado, let's get started. So first, I just want to quickly talk about this new challenge and sort of explain why we've designed AI Engineering Lab, and sort of like what the reasoning behind this is. So students are already using LLMs extensively, and the workforce is too. So I quickly want to go through like an example. Let's say we have a business student and they're tackling like a data analysis assignments in like maybe a business analytics course. And for this, they have to write some code. A couple of years ago, they would just write the code line by line. But nowadays, they might chat with an AI to generate the solution. And this is sort of a reality that a lot of professors have seen, and a lot of professors we talk to are seeing this as well. Generative AI tools like ChatGPT sort of transform how we approach coding, and especially for people where coding is not the main sort of objective. In the workforce, in 2024, this was a study done by McKinsey, already 72% of organizations have adopted AI in at least one business function. Today, that's probably much more. And this sort of is a clear message from an educational perspective, which is like the graduates of today, not just CS majors, they will enter a workforce where AI will be ubiquitous. And the responsibility for educators means that we have to prepare students for this reality. And a lot of educators are thinking about this and how to do this effectively. And especially as it relates to coding, from our perspective, that means teaching them prompt engineering, which is the skill of crafting effective inputs for AI. And this should be a core part of coding education. So I'll quickly go over sort of how prompt engineering can empower CS and non-CS majors to apply AI, but then also talk a bit about AI-assisted learning, how that can boost coding education, and how this sort of cultivates critical thinking and sort of create key workforce skills that our graduates will need in the future. So let's quickly talk about looking at sort of coding for non-CS majors in this new sort of AI world. And what we see basically students outside of computer science, like business, finance, marketing, and a bunch of other areas, engineering, they are already expected for many years to use sort of coding as a tool for like data analysis, automation, problem solving, and it's sort of a core tool in their field. But a lot of these students may find traditional programming daunting, and AI can sort of level the playing field here. As sort of an author put it, AI can democratize programming, making it more accessible to a broader audience. And especially in the context of sort of non-CS majors, they are not writing production level code. They're using coding as a tool. And instead of sort of wrestling with syntax, they will describe what they need in natural language, let AI generate the code, and then sort of move forward, read the code, and then sort of move forward for that. One educator sort of put it like this, which is chatting with the AI is how you get it to produce responses for you. In essence, your chat prompts are how you program the AI to do things for you. Instead of needing to write computer code, your written language is how you control the AI. And sort of with this, you get to a solution. So this basically means that with prompt engineering and sort of key fundamental skills of what the AI produces, as a non-CS major, I can write programs by writing English or any other language, which can be sort of a game changer for those who have domain knowledge, but lack sort of the extensive coding training that you might need. And that domain knowledge is important, and I think the fundamentals are also important. But we do see that some educators might ask a question like this, which is, if code can be automatically generated, should we still teach students to write code manually? Should we shift it from coding to understanding and leveraging these automatic programming tools? And we see that a lot of people sort of are asking this question, but all the people that teach coding will say like, no, maybe we shouldn't go this far. And I think that's right. We need sort of a balance. Non-CS students benefit from learning the fundamentals, but we should also teach them to leverage AI as a coding partner, and especially using AI as sort of a way to cultivate computational thinking without them having to, focus so much on the syntax and the exact specifics of a programming language. And if we integrate prompt engineering exercises into assignments, these students, business finance students, they can really learn how to translate problem-solving steps into prompts. So, for instance, like a finance major might, prompt an AI to create a Python script that analyzes like sales trends. A marketing student can use AI to sort of build like a website. And these are things they might not have attempted solo in the past, but now with sort of AI assistant and some kind of fundamental knowledge, they can sort of accomplish this. So we can really see prompt engineering and AI sort of becoming a bridge between the intent and a working solution. So apply coding and AI in coursework, and then eventually apply it on the job. And this will really make these students much more valuable to the workforce later on. If they are able to apply coding skills at a sort of broader spectrum, and you sort of see this in tons of businesses where this is becoming really an important part. And of course, a similar thing is there for CS majors as well. Although I think the balance there is still more towards the actual coding aspect. There you really need sort of more fundamental knowledge of coding, because you need to sort of be able to evaluate what the AI outputs more. Next, I want to sort of quickly also talk about sort of how AI can be a learning partner in coding education, and sort of be a tutor and accelerator for learning. So a lot of sort of recent studies highlight the benefits of using AI assistants in programming education. It sort of can really give students more direct feedback, provide a more supportive environment, and especially when you sort of pair this with more traditional auto grading. The more traditional auto grading is, of course, generally, if you use it for grading, still a lot better in the sense that the result is always the same. So that's like a big advantage. But it can be hard to understand what the auto grading results are for a lot of students. And if we add like AI to this, then the feedback can be used by the AI assistant, and it can sort of translate this to student more effectively. And sort of a lot of these studies, like where they use things like ChatGPT as sort of a programming assistant, this is quite effective. So not necessarily using AI for grading. We're not really supportive of that at the moment, but really as a sort of feedback layer, I think it's getting really good at that. And also these studies, basically with these studies, we see like that if students use AI as a learning partner, we see sort of improved coding proficiency, The explanations get of a high quality, and sort of students cultivate deeper understanding. And I guess this sort of anecdotally, this also works, right? If students, receive a lot of explanations, examples, debugging help, let's say from a traditional TA, they really overcome roadblocks a lot more easily. And if we can sort of, emulate that with AI, then that can be of great help, especially for those students in colleges where they don't have access to TAs all the time. And also, instead of getting stuck on a syntax error, missing semicolon, or an error message, they sort of learn from the AI's guidance, and then they can move on to solving the actual problem at hand. Finally, they're a personal tutor, basically available 24/7, and we already see this. Like a lot of students, they are using things like ChatGPT. If they're getting stuck, they're just putting their question in there, and they're getting feedback back. But a thing that a lot of professors might say, oh, well, they use ChatGPT or they use some other AI model. Does that mean the students are learning less? And I think we can make sure that that's not the case. It's important to sort of implement these models thoughtfully, making sure they're learning more effectively. Especially if you talk about prompt engineering and stuff, you need to figure out ways of doing assignments and assessments where they need to understand what the AI produced code is doing, sort of verify it meets requirements, and then refine it through sort of iterative prompting. As one other educator put it, giving AI coding tools to students is like giving a power tool to an amateur. And basically, without guidance, there's a risk they could misuse it or skip learning fundamentals, which is sort of destructive. But with proper instruction, that power tool can sort of accelerate the building process, constructive. And basically, as instructors, we should ensure students can use these tools properly so they learn faster and with greater confidence, instead of the other side, which is sort of bypassing the learning process. And we think that if we blend sort of prompt engineering, traditional coding exercises, we can achieve that balance. So let's quickly talk about the next step then. So the goals of basically introductory programming in a lot of contexts, both CS and non-CS, is that we want to teach students problem solving and computational thinking. And some might worry that this makes students passive or weaken their problem solving skills. In practice, I think we're seeing the opposite. When students learn prompt engineering, they're also honing critical thinking and analytical skills. They still have to see the problem. And it's sort of a new way of doing this. And basically, writing a good prompt requires a deep understanding of the problem. And then also being able to communicate that clearly. A lot of things you need to be able to do to code it. Just the coding layer is a little bit less important. So they really must think about what they're asking, why the answer is correct or incorrect, and how to improve the result. And this is also really why in the workforce, you see that people that are really good at programming, they can really take AI and sort of make themselves much more effective. But people that are not really that good at programming, they are not very effective at using AI. They might get pretty far, but then they get stuck and they don't know how to solve the problem. So basically, if you want to be effective with AI, you sort of need to have that understanding. And I think that maps pretty closely to the general reasoning. And I saw this as a Reddit user put this, and I found this pretty good, which is prompt engineering is just critical thinking. The reality of prompt engineering is that it requires knowing why a response is weak, and it helps you refine prompts. So you really need to be able to know what you put in, know what comes out, and know how to refine it. And basically, this prompt engineering forces students to evaluate AI outputs critically and articulate improvements. And basically, this AI literacy, we could call this, is becoming sort of an essential workforce skill. And learning sort of how it can help you code can set you apart in the industry, as we sort of said before. And we see this in sort of higher education, but even in sort of K-12, like high school, middle school. Some experts were noting that AI competency and prompt engineering will soon become essential skills for every student, as critical as office software proficiency was in the past. And we can sort of see this throughout all of the research. So being able to effectively direct AI is sort of entwined with problem solving, I think, is what we're seeing. And by teaching prompt engineering, we can not just teach students to code with AI, we're teaching them sort of a new form of analytical thinking, AI fluency, that will serve them later on. So to conclude sort of this new challenge and sort of what we're doing about this, in our opinion, like prompt engineering really is more than a buzzword. It's a powerful tool to make coding and AI accessible to all students, and a training ground for the critical thinking skills our modern workforce demands. And especially by teaching sort of non-CS majors how to harness AI in their coding projects, we can enable them to apply this to their field without sort of being bogged down by the technical barriers in the beginning. And finally, what we can also see is that if we use it appropriately, AI assistants can enhance learning. We can make sure students stay more motivated, learn faster, focus on problem solving, creativity, instead of syntax and setup. So again, a lot of people sort of make AI they compare it to like the calculator or Google or things like that. And I think we should embrace the prompt engineering part as sort of the key component in coding education, especially sort of introductory level. And then basically a tool that if we introduce this with guidance, we can push students to higher levels of understanding and productivity. So this also means we sort of have to work on designing assignments where students can use AI. We have to design new ways to teach prompt engineering, and basically to help you integrate this into your education. We are introducing the AI engineering lab, and that is basically a fully guided module that integrates with your LMS. It's powered by CodeGrade on prompt engineering for coding courses. The initial setup is basically focused on Python because we see that's sort of most used in non-CS and CS. So it's a good starting point for us. And basically, it has 4 parts to this. We have sort of Python fundamentals. So we do think it's important that students, learn some basics about programming. So you need to have some fundamental skills. And this is even more important in sort of CS. Then it comes with core concepts on prompt engineering itself. So concise materials to explain like what is prompt engineering, what are LLMs, and all those things. And then the big part is this is really focused on doing. So we're introducing a new question type called prompt problems, based on some great research that's been done at 6EZ in the past year. And finally, AI mini projects, which are sort of more traditional, like more real life coding assignments that go a bit further than without AI. So students get an assignment, they have to use the AI assistant to implement new things into this assignment. And all of this comes with sort of 60 plus of those prompt problems and over 10 of those mini projects. So you can really sort of pick and choose what you want to do with it. In terms of sort of the syllabus of this, it basically looks like this. Section 0, Python fundamentals without AI. So just things like what is Python, basic stuff like loops and all those things, functions. Then a section on introduction to prompt engineering, which basically introduces what prompt engineering is. And then there's a big section to cultivate computational thinking with these prompt problems, and I'll introduce them in a second what those are. But there's basically a large section where they will just practice their skills. There's a section on advanced prompting, which sort of has goes into more details, like what is effective prompting, how can you refine prompts, how can you integrate that maybe into a product, optimizing outputs, a little primer on like Markdown, because that's quite important in prompting. And then finally, there's a module on ethical use of AI in programming. These sort of core concept pieces of text, they're quite concise, and we really want students to do stuff. But here are some samples. So for instance, our introduction to prompt engineering, it just goes over, why it matters, what it is, why LLMs matter, how you can apply it in programming. And this also comes with some formative multiple choice questions and prepares students for the prompt problems that are after this. If we look further ahead to sort of the advanced prompting section, it starts with sort of more prompting techniques that are sort of the latest in the research on prompt engineering. And this sort of prepares students for those AI mini projects. And then after that introduction to prompt engineering, students basically will get prompt problems, which is sort of a new innovative question type where students will get some kind of problem statement where they get a problem they need to solve with computational thinking. They will write a prompt to solve the problem. They press check answer, and then code gets generated. They're able to see the code, but they cannot edit it. So the whole code only gets generated from their prompt. And then finally, that code is auto-graded and students receive feedback. They can then use this feedback to refine the prompt and sort of solve the challenge. So here you can see that in this case, a test on the code failed. Students can read through it, they get some feedback, and they use that to sort of modify the prompt, press check answer again, and then code gets generated. So let's have a look at what this looks like. So this is that same specific example. Now in CodeGrade in our course, and here we get a question statement. And the first thing I might try to do as a student is just copy paste this in, and then press check answer. And then what will happen is we can see code getting generated. But as we can see, our test failed, except on an empty data set it works. So we have we're somewhere, but we're not quite there. So what you can see in the initial example here, we're given a table of monthly sales data. Each row contains a product quantity and unit price, but we're actually not sure what the format is because that's not really specified in this specific problem. However, in the test, we can see, we do get the format here. So we can now use this to sort of refine the prompt. So instead, I'm going to write a good prompt, which is write a function list. All right, so something like this. And now we can press check answer again. And now we can see we get some new code and we can verify this. Okay, this looks pretty good. And now we can see all the tests pass. and now I've sort of solved this problem. So as a student, I didn't really have to think about like, oh, how do I have to write a loop and all those things, but I did have to think about, how to solve it. So you can see we need to, specify the function name, we need to specify the input, and we need to specify what kind of output we expect. So this is sort of a simple example where students do this. We sort of have two types of prompt problems. We have these sort of more real-life examples, which are great for sort of non-CS. And then we also have more, more like CS kind of examples. So here we see a different example where we have to write a prompt to generate a Python function that follows the sample run. So in this case, we sort of have to figure out like what's going on here. So again, we might try and copy paste this in. That will not work. But we actually have to, figure out here, oh, this is about like the Fibonacci sequence. And if we pass through, we should return all the numbers that are part of the Fibonacci sequence. And then if it's false, we should return all of the numbers that are not part of the sequence. And again, we sort of check answer and we sort of work with the system to figure out what's going on. So again, from this prompt, the code will get generated. And you can see that's going on here. It's actually using nested functions and all those things, which is great. And then like my test will run on this. So again, I can do this, and then I can sort of go to the next one, and then the next one, and sort of figure out all of these problems. That's our sort of prompt problem question type. And again, we have about 60 of these built right now. And sort of, if you decide to integrate this in some way into your course, we'll sort of work with you on figuring out like which ones work and which ones don't work for your specific course. The next step that's part of sort of this module are AI mini projects. These are sort of larger projects where students get some starter code. They're introduced to concepts that haven't been covered yet. And then with the AI assistant, they have to implement improvements to the code and sort of develop an understanding of the project. So within the platform, we have a built-in AI assistant. That's powerful. We're running Claude as our LLM model. And we can basically talk to it, and the AI assistant will reply with answers, and it will write code for us and all those things. And then, here we have an example. We're sort of working with the AI system to make this specific example sort of more efficient, and it's giving me some suggestions. I might implement these, and then whenever I press hand in, what will happen is, well, first of all, it will submit this, it will run automatic tests, but then also as a teacher, I can basically see the conversation that a student has had as well. So this is also sort of a powerful feature where you as the teacher have more insights into what the students are doing. So here I can see sort of everything that's going on. And that's the other sort of part. And these are sort of larger projects. And again, these are sort of from more pure sciencey subjects like, Sudoku solver to more sort of real life examples where they might analyze some sales data and all of those things. So again, the syllabus of this specific module, Python fundamentals first, which basically follows, it comes with a lot of sort of quizzes on Python programming, prompt engineering, computational thinking with prompt problems, and then advanced projects, AI mini projects, and all of those things. Right. Quickly want to highlight sort of next steps on this then. What is this? What are the next steps to get this into your courses? we will launch AI Engineering Lab, so it will be available May 1st. And it basically comes with all of this. So we have quizzes, assignments, core concepts, prompt problems, mini projects. It also comes with full code grade access, and you can customize assessments. And we'll offer like onboarding and customization of the content as well. And this is sort of our launch pricing, whether you're a new customer or existing customer. And we'll also be able to offer, before we'll have sort of a limited supply of free pilots available where you can sort of try this out in your first course at no charge. We have plenty of time for questions yet. I do want to put this out here. So if you want to explore AI Engineering Lab, you want to sample the content and all of those things and the problems, you can just reach out to me directly and I'll help you get set up.